Hello, everyone. Welcome to our Tech Talk series. I'm Drew Peer, Strategic Account Manager at Engineering Industries Excellence, or INDEX for short, and I'll be the moderator for today's discussion. I've spent my entire 14-year career working with discrete manufacturers, and at INDEX, I help companies to solve their business challenges using digital enterprise solutions like PLM and MES. I'm excited to guide the discussion today on battery innovation and transformation. So battery manufacturing, as we all know, is evolving rapidly. As the world accelerates towards electrification, we're seeing historic investments, bold sustainability targets, and breakthrough technologies, all bringing new challenges in scaling, quality, and supply chain resilience. That's why we brought together experts from INDEX and Siemens to explore how digital tools, smart manufacturing, and strong partnerships are shaping the future of the battery industry. From INDEX, we're joined by David Caparis, Director of Discrete, delivering manufacturing shop floor IT solutions. David brings over 2 decades of experience and a deep background in digital transformation. David now architects integrated systems that bring Industry 4.0 to life. From Siemens, we're joined by Katharina Gerber, Customer Engagement Manager for the battery industry. Katharina brings over 15 years of experience and leads initiatives across direct lithium extraction and dry electrode processing. She's also VP of NatBat International and a champion for sustainable battery innovation. Now let's jump in and explore where the battery market is headed and how we can lead the charge together. All right, so to begin, let's take a step back and look at the overall direction of the market. Where do you think the battery market is headed in the US?
The US battery manufacturing market is undergoing a significant transformation, driven by substantial investments, technology innovation, and strategic policy support. Companies like Toyota, Hyundai are investing heavily in battery manufacturing. Toyota just opened up an $8 billion battery plant in North Carolina set to produce 30 gigawatts annually. Notable development in battery manufacturing has been design, the emergence of sodium-ion batteries as a viable alternative to the traditional lithium-ion batteries. Natron Energy, a US-based company, has pioneered commercial production of sodium-ion batteries, making a significant shift in battery technology. Lyten, a super materials company, is using their 3D graphene to produce more energy-dense and lighter lithium-sulfur batteries.
Yes, this is a big and complex question, and honestly, the US battery ecosystem is evolving rapidly, and it's shaped by a convergence of geopolitical, financial, and technological forces. So let's break it down. Geopolitically, there's a clear trend towards onshoring as many elements of the battery value chain as possible. And this doesn't just include battery cells, but also upstream components such as graphite, silicon, and cathode materials and minerals that we use for manufacturing of cathode materials. Several American startups are now moving beyond pilot scale and preparing to deliver domestically produced materials. We're also seeing a wave of joint venture announcement, as David mentioned, particularly in battery manufacturing, and significant investment from established players from Korea and Europe who view United States as a strategic growth market. Financially, 2025 has been a challenging year for many small and medium-sized enterprises. As you probably know, federal funding has been slowed down significantly or frozen in some areas, and private investors have grown cautious about capital-intensive industries. As a result, we are witnessing a wave of consolidation. Startups that can demonstrate strong technology and clear market pull, especially those who are able to secure partnerships with large industrial players, will be the ones to scale. Expect more emphasis on digital tools to streamline development cycles, reduce costly prototyping, and compress time to market. And technologically, the cooling of EV demand is prompting many players to pivot towards lithium iron phosphate chemistries that can be used in stationary energy storage systems. And at the same time, niche technologies with high performance characteristics are gaining traction in sectors like aerospace, marine, and defense, area where unique requirements can command premium solutions. Meanwhile, sodium-ion and solid-state batteries are approaching commercialization, and will likely find their way into targeted applications in the near future. So in short, the US battery market is a highly dynamic space undergoing a lot of realignment right now. And despite near-term headwinds, it remains an engine for innovation and long-term strategic importance. There's a lot to watch and a lot to build.
Very cool. All right. So clearly there's a lot of momentum, but there's also a significant gap between demand and domestic capacity. The US battery production pipeline is still substantially behind demand forecasts. What are the implications if that gap isn't closed quickly?
Great question, Drew. Simply, the US would remain heavily reliant on foreign, primarily Chinese, battery manufacturers to produce those batteries. Our current domestic capacity is 60 gigawatts annually, but the projected US battery demand by 2030 is approximately 1,000 gigawatts annually. Without the US's ability to satisfy this demand in battery supply domestically, it's going to hinder the market leadership locally, but also in competing global markets. For example, automotive makers struggle to meet production targets due to battery shortages for energy storage systems and electric vehicle adoption. So we can see that connection. Closing that gap will require accelerating factory construction, securing raw materials, and cutting-edge materials like 3D graphite, or having trained, skilled workforces ready and adopting technology for that rapidly scaling of manufacturing capabilities here in the US.
Okay, while the US has significantly expanded manufacturing capacity for EV batteries, demand for new electric vehicles is not growing as quickly as projected. At the same time, demand for battery cells for energy storage systems, or ESS, has surged dramatically, leaving us far from having enough production capacity. How can we rapidly close the gap to meet that skyrocketing ESS demand?
Yes, this is a big concern across the industry. And the first step is to rapidly close the ESS battery cell supply gap by finding efficient ways to retool existing production lines. For example, LG is already doing it. They retooling their NMC production line that was used to make EV batteries to make now ESS cells. And this is driven by the rise of data centers, and they are really energy hogs. They require a lot of energy, and we need a lot of ESS battery cells right now. So second, we need to accelerate the development of new chemistries that are maybe more suitable for long-duration energy storage. For example, zinc-based and sodium-ion batteries are particularly promising in this regard, and companies such as Peak Energy, Natron are working on commercialization of these technologies. However, these technologies face challenges with unestablished supply chains and manufacturing differences. For instance, sodium-ion battery cells require different electrolytes that still need to be developed and proved in applications. Also, they may require slightly different manufacturing tools. So we are not, there is no off-the-shelf solutions for that right now. And so to scale up with technologies, the new emerging technologies, as well as to retool the existing lines, the industry must invest in fast-track prototyping and development of these technologies to bring them to commercial readiness as quickly as possible.
Fascinating. Okay, let's talk a little bit about something a little more strategic, where companies are placing their bets today. Why do you think the US manufacturers of today are currently prioritizing production over design capabilities, and what risks might this present long term?
You know, that's very interesting. In the US market, they're prioritizing production over design primarily to meet urgent demand, capitalize on incentives, and compete with global leaders like China that have an advanced start from us. While this focus helps rapidly scale domestic output, it carries significant long-term risks. Without a robust investment in design and innovation, US firms risk becoming commoditized producers dependent on foreign intellectual property, losing ground in that next generation technologies and limiting their ability to serve emerging markets with specialized battery needs. This imbalance could ultimately undermine the US's competitiveness in both in clean energy transition and high-tech manufacturing.
Yeah, there is a massive pressure right now to build fast. Investors want quick returns. They're not patient. Timelines keep getting tighter, and everyone is racing to keep up with big players from Asia who scale up at lightning speed. Naturally, that pushes the focus towards cranking out batteries, get the gigafactory up, lines running, product out of the door. But here's the catch. If you are not building strong design capabilities at the same time, cell architecture, pack integration, thermal management, you risk locking yourself into yesterday's tech. Just look at how cumbersome it is to switch from NMC to LFP on an existing line. Now imagine trying to pivot to solid-state batteries. If you don't have a way to model and test those changes in virtual replica of your plant, you are forced to tinker in a real facility, which will slow you down and it will be very expensive. That is how you end up stuck with legacy tech while the market moves on. The smarter play is tying design, simulation, and manufacturing together digitally. And at Siemens, we call this the digital thread. It's what lets you explore new chemistries, iterate faster, and de-risk scale up without burning capital on trial and error. So yes, to production matters, but long-term competitiveness comes from building that design muscle along the factories.
Okay, so with that in mind, how are manufacturers responding to these pressures in real time? How are those manufacturers adapting to some of these market demands?
So it's an intense market. They're adapting to a mix of rapid capacity expansion via strategic partnerships, adopting technologies like an MES system or the MOM umbrella of capabilities. Now, to meet that surge in battery storage needs, companies need to really build large-scale gigafactories across the US. And they're often collated with an automotive plant nearby or renewable hubs to reduce logistic costs and improve responsiveness to the supply chain. But they're also forming alliances with raw material suppliers, which is very critical for some of the key critical raw materials. They're working with technology companies. They're working with recycling firms to secure long-term supply chains to reduce dependence on the foreign sources. Now, some very forward-looking manufacturers are beginning to invest in technology, which allows for a more modular and flexible production line. Karina mentioned that earlier. The ability to change from one line to another is very critical for innovation. Now, this can also help accommodate multiple chemistries, multiple cell formats, allowing the technology to help you move faster to these new technologies like sodium state and solid state. Manufacturers know that battery manufacturing is all about maximizing yields. To do that, you need to mine data, and you need to mine it fast, and you need to make it easy to allow you to then use that data to maximize those yields. And that's why companies are investing heavily in an MES to stay ahead of that.
All right, so as David alluded to, many companies are investing heavily in these gigafactories, but scaling successfully is not just about adding capacity. What do you think truly determines whether a manufacturer can ramp up efficiently, Katerina?
Yeah. Up until now, we have measured scaling in terms of physical speed, meters per minute, or cells per second. But in today's gigafactories, the real differentiator isn't machine speed, it's the speed of insight. I'll explain what I mean by that. Think about what's happening on the factory floor. Hundreds of machines running at speeds no human can visually track. Coating lines run at 120 meters per minute, slitting machines at 200 meters per minute. Individual cells stacked and placed in a pouch every 1 to 3 seconds. At that pace, operators rely entirely on sensors and machines to capture data. The bottleneck isn't just physical production. It's not about how many machines you buy or how big is your building. It's how fast we can take all those signals from the shop floor and make sense out of them and act. And in many factories, detecting a yield drift can still take hours or days. And by then, thousands of cells already scrapped. And this is why Siemens, MES, and pack solutions are so critical. They turn raw machine data into actionable insight and feed that data directly into a virtual model of the plant. This enables a closed feedback loop where we can continuously monitor, learn, and improve production in real time. Scaling a battery factory today isn't just an industrial challenge, it's a data systems challenge. The manufacturers that can collect, analyze, learn, and act on their data fastest will master the speed of insight and win the learning race and ultimately the scaling race.
All right, let's go a little bit deeper into some of those risks. As you scale, obviously there's going to be some roadblocks along the way. What do you feel is some of the risks that you see with some of these battery manufacturing processes or just with these manufacturers in general?
Well, battery manufacturing carries significant risks, and it stems largely by the need for precision-driven processes that must scale. In a high-speed production, you really need that. The most pressing risk is quality control failure. A single defect, not caught right away, will cause a large amount of scrap or low-quality product. In a high-speed production environment, even small inefficiencies or variances can rapidly snowball into a yield loss or unusable output. Another risk is not investing in an IT system like a manufacturing execution system. An MES can gather that data in real time and give you real-time analytics. Otherwise, you're blind. You have to go spend days and days and weeks after the fact, which is not supporting what you need, which right now, a battery a second can cost you a lot of money. Without that tightly integrated system to monitor and adjust and optimize every step of production, from electrode coating to cell testing, manufacturers won't be able to keep pace with the industry leaders that did invest in that technology. Companies lacking that digital backbone face high scrap rates, lower throughput, and difficulty meeting customer specs or regulatory compliance as those change, or overall just erode your profitability. In short, speed is essential, but without precision, intelligence, and agility, speed alone can only sink a battery manufacturer. Here's an excellent example. Back in 2016, the Samsung Galaxy Note 7 recall. The device experienced multiple incidents where the battery was overheating, combustion, leading to a global recall. Now, investigators found that it was because of the design flaws, while the replacement batteries that came later actually were due to manufacturing defects. That's because they had issues with the way the electrode positioning and insulation was occurring. And these failures were attributed to rushed production processes aiming to meet high demand. And this really highlights the critical importance of strict quality control and having an MES system to really enforce that throughout the entire manufacturing cycle.
Battery manufacturing is uniquely complex. It's not just assembling parts, it's chemistry, it's mechanical and electrical engineering, and fluid dynamics all rolled into one. It's also a mix of continuous and discrete processes, which makes it far more challenging than traditional manufacturing. And with that complexity comes risk. First, quality risk. Tiny defects or slight process changes can cause big issues. Poor performance, warranty claims, even safety recalls, as David just mentioned. And when you are making millions of cells a day, catching problems early is critical. That's why inline inspection, traceability, and closed-loop quality control matter so much. Second, scale-up risk. Moving from lab to pilot and then to full gigafactory is a huge leap. Without a strong digital foundation, simulation, proper planning, things get messy. Scrap rates rise, timelines slip, and costs skyrocket. We have seen it on an example of Northvolt. We have seen projects that fall behind just by skipping early digital validation and trying to move fast. And third, supply chain risk. The industry still relies heavily on global sources for lithium, nickel, and cobalt. That creates volatility in pricing and availability of materials. Without digital tracking or resilient supply chain, you are exposed. Even major players like LG have faced shortages that disrupted delivery. And finally, capital risk. Building a gigafactory costs billions, and investors and customers have little tolerance for missed milestones. If scale-up doesn't go as planned, you are out of the game because battery manufacturing eats time and capital very fast. Building a strong digital foundation, simulation, data-driven planning, and connected operations can mean the difference between scaling confidentially or starting out.
Okay, so speaking of scaling, starting a new battery facility, massive undertaking, as you know. What challenges do these manufacturers face when they're starting a brand new battery facility?
So given the precision required in manufacturing and the knowledge, the facilities have to be equipped with the right systems, the right people, the right talent. And in high volume, high speed production, it introduces unique challenges that isn't just about complex manufacturing or rate production. It's about chemistries, it's about discrete processes all coming together. And even if a small part of your process fails, it can cause major issues, quality, recalls, brand damage. That challenge is very real for a company starting up a new battery plant in the US. Another factor is manufacturing requires a really specialized workforce. Getting everyone into a room and talking a battery line is difficult. Understanding each other is difficult, especially when you haven't lived it for the last 10 years. And that's what is a challenge. It's a real challenge for battery manufacturers to bring that talent together and understand their process, to be able to define it. Because once you define it, then you will be able to understand what you need to do to be successful. What kind of training programs, what kind of technology, what kind of data do you need to collect? Now, all of that comes back to getting good talent. So attracting talent in the market is very critical. So having tools like a digital model is very important because you can talk together about a digital model before you even have a physical plant.
Oh, there is a long list, and most of them hit all at once. Starting a new battery facility is like building a spaceship while you are flying it. You've got to move fast, but you can't afford to get things wrong. First big challenge, time. Everyone is racing to get facilities online, especially with IRA incentives and demand from OEMs piling up. That creates tight deadlines, and traditional methods just can't keep up. That's where Siemens digital twin technology really shines. Using tools like Technomatics and plant simulation, you can design and simulate your production line virtually before a single machine is installed. That way, you are spotting bottlenecks and optimizing layout upfront, not after you already went live. And second, complexity. Battery lines are no joke. You've got everything from slurry mixing to calendaring to formation and aging. It's a lot to coordinate. With Ops Center execution tool, we help manufacturers bring visibility and control the shop floor. You can track every cell, monitor performance in near real time, and ensure quality from start to finish. Third, as David already mentioned, is a big one, workforce readiness. These facilities need skilled people, and most regions don't have a ready-made battery workforce. Lack of experience is a big barrier. That's why companies are turning to Siemens Accelerator to build out comprehensive digital training environments. Using Annex and Team Center, you can create standardized processes, digital work instructions, and even onboard teams using virtual reality and simulation-based learning. This kind of immersive, hands-on training dramatically reduces ramp-up time and ensures consistency, critical when you are hiring at scale. And finally, risk. Scaling without validating first can lead to high scrap rates, downtime, and an underperforming product. Using tools like Sim Center, manufacturers can model, for example, thermal behavior of battery cells, mechanical stress, electrochemical performance early in the design process. That helps ensure the battery and the process will perform as expected, even before it hits production. So yeah, starting a battery facility is a major lift, but with the right digital tools, you can go fast and smart. Siemens brings that full digital thread from design to production to quality, so you are not just building a factory, you are building a foundation for a long-term success for your company.
What are the top things that CIOs, CEOs, C-level executives should prioritize right now for the success of a new battery plant?
So in that position, you have to think about overall success. And when you establish a new battery manufacturing plant, it means really prioritizing the right strategies and technologies to ensure long-term success. So one of the key things is on the technology. Get the right MES solution in place to give you the data analytics that you need to make smart decisions quickly. That's a key point for any executive to understand. But there are several interconnected factors that should be considered. Given the pace at which battery technology is evolving, solid state, sodium ion, and so on, these manufacturing systems are there to be flexible and help you scale. So as you change, that system allows you to change quickly. Module production lines, the design of that production line can be reconfigured easily to allow new chemistries and innovations. And that MES system will allow you to do that changeover. It will allow you to track it, and it'll let you collect that data and make smart decisions quickly. So to be competitive in your market, make sure you have the system that collects you the data to do the analytics, and then you'll stay ahead of the curve.
Great question. We hear this a lot from leadership teams trying to get these massive battery projects off the ground. If you are a CIO or CEO and you're launching a new gigafactory, there are a few priorities that can make or break success. First, build your digital foundation early. Don't wait until after construction starts. Using something like Teamcenter to create a centralized data backbone keeps design, engineering, quality, and production teams aligned. No silos, no version control headaches. Plan for scalability. Many companies start with homegrown MES to save costs on a pilot line, but when they scale up, that solution can't handle full production. Then they are forced to migrate to a professional MES system, and that can be expensive, time-consuming process because you also have to move all your data. Choosing a scalable platform like Siemens Ops Center from the start avoids these growing pains.
Katerina, let me interrupt you for a moment.
Yeah.
I see that a lot in the market where these companies that are starting up, they're investing, but they don't invest in the technology platform. They go and buy the cheapest MES on the market, and they have instant regrets. And they come to me and say, how can you scale me up? And we start having discussions with them about making sure they have the right technology platform that allows scalability and growth with their company. Because when you're in that very beginning small plant, it may work for you. But when you get to that gigafactory size, you really need the right technology like the Siemens portfolio to make it happen.
Good point, David. But let's go back to the question. So another thing that you need to pay attention to is design for flexibility. Battery technology is evolving fast, switching chemistries, formats, and pack designs. With technomatics and plant simulation, you can digitally design and test different solutions, different scenarios before committing to hardware, making your plant adaptable to future changes. And another point I want to mention, you need to connect the shop floor to the top floor. A lot of delays happen when MES and ERP systems don't talk to each other. With Ops Center execution fully integrated with PLM and ERP, you get real-time traceability and leadership gets actionable insights to make faster decisions. And last but not least, train your workforce digitally. Skilled labor is scarce, and waiting to train until equipment is installed slows the ramp up. Using digital twins and virtual reality, operators can practice on virtual machines before they even delivered, so they are ready from day one.
We talk a lot about quality because it's really important to battery manufacturing. And actually, it's a really good point because sometimes when you talk about quality, you forget that quality isn't on-the-spot instant decisions. The quality decisions in the battery line can take time. The slurry is going to get produced. You're not going to stop the line. You're going to continue the line and take a little bit of risk because the results are positive overall, but that final test result may come back a day later or 2 days later. Same with formation. You're not going to know the results right away. So you don't know your exact yields, quality is really, really important when we talk about an execution system.
And to that flexibility point, David, you and I know quite well, working with greenfield battery manufacturers, you got to be flexible because things are changing literally every day. You need to have agility, have the right tools in place that can allow you to change and quickly adjust your direction. So very good point, Katerina, for sure.
You know, you also have to think beyond launch of your production. True success isn't just getting the plant running, it's building a platform for continuous innovation. A Siemens Accelerator gives you a scalable digital ecosystem that grows with you. Whether you are adding a second line, or introducing new chemistries, or integrating recycling workflows, for example. So bottom line, prioritize digital from day one, pick technologies that scale with you, and use simulation and connected systems to stay flexible. The leaders who do this avoid costly rework and delays, and they're the ones winning long term.
All right, so now many of these facilities are being relocated or reconfigured here in the US based on past successes, often in Asia. How are companies addressing the challenges of relocating some of those battery production facilities originally designed in Asia and brought over to here in the US?
Drew, it's not easy. It is not easy. All that IP and technical talent is still in Asia, and you have to bring it to the US market. Relocating a line designed in Asia into the US has different factors, right? There's the regulations in Asia versus here. There's the way that work happens in Asia versus the US. So there's a different mindset you have to adapt to. And US facilities really have significant challenges there because they have to make sure their infrastructure is set up, that their equipment integrations will work the same way as planned in the previous source plant. Now, these companies know that, and they're redesigning their layouts to meet the needs here, to maximize and optimize automations. And that means investing in domestic supply relationships, building vertical integration strategies, and ensuring that not only the technology and the plant is there, but your supply chain is there to feed that plant. They're also focusing on workforce development through training programs, knowledge transfer, and overcoming some of the hurdles of getting all that knowledge into the US market. They do that through joint ventures, bring some of the talent from the Asia area into the US market for a minimal amount of time to get that education in place. But that's on the talent side. Technology, though, companies are leveraging the automation, AI, machine learning, large language models that are available today to improve the efficiency and quality control in the US market, where maybe because labor is more cost effective in Asia, it's done by people. Here, we're leveraging technology to make it more cost effective, and also introduces the fact that in high volume production, we want that, right? We need the systems to be automated. We need to make quick decisions without people intervening. This approach, where there's multiple factors, really helps companies scale that line into the US market, because now they're thinking about leveraging the latest technology for scaling to ensuring the compliance here in the US, and that helps them stay very competitive. Not just doing a copy paste, but doing more of a shift left and then enhance. And that's what's going to drive the US market leaders.
Yeah, a lot of things to consider. Never quite goes as planned, does it?
Yes.
Basically, they have this working production facility making batteries successfully in Asia. Everything's running smoothly, and they expect, oh, we can just take that technology, those machines, that exact layout, and bring it over here, and it's going to run exactly the same, no issues. Never works out that well. In our experience, it's always extremely difficult to translate that technology and that success in production from one country to the other because of all these different challenges with the workforce, the technology, the machines, the layout.
That's where I think Siemens technology really comes into play. The digital model, the digital thread, leveraging Team Center, leveraging Op Center, leveraging the connectivity to the shop floor, knowing this, but bringing all the benefits, right? It's one thing to bring the hardware over, it's another thing to bring the software platform over. You want in the US market, you need, not want, you need a reliable, supported application software layer that's going to give you the analytics and information you need. And this is something that all companies that are building up new plants need to be thinking about. I have a client now that is going through the same challenge. They're trying to lift and shift the line from Asia over into the US market, but in Asia, they decided to go completely custom with local vendors. And when I say local, I mean small local vendors that you call them up and say, hello, we're kind of buddies. Here in the US market, that's not going to work. I need someone I need to be able to hold responsible and say, I need support now. Get your entire production team in. I need an R&D team helping me, making sure I can produce batteries. So that's where I think the Siemens technology platform really is supporting this shift from lift and shift, but lift, shift, and enhance. That's the key point. It's not going to be as simple as copy and paste, because also the vendors that are building the equipment here will build it differently, right? There's line builders in Asia, there's going to be line builders here in the US. Now, in some cases, those line builders are still in Asia and then ship the line over, and then that's a little bit of a different challenge then, because then you have to talk about communication. How do I get my software platform and aggregate and bubble up all that data to the surface sufficiently and correctly? Well, again, the Siemens portfolio has a great connectivity framework for the shop floor to be able to integrate that data and be able to put it into a single repository to be able to do the key analytics, predictive and machine learning kind of analytics, which is really important. This is what I think a lot of manufacturers are really facing right now, that challenge.
And David, what do you think about companies that trying to save money and cost? They buy machines from different vendors. They buy, legacy machines, maybe from different facilities that went out of business. How they can scale up their production?
So I think every business needs to make some decisions, risk and reward. A company that's gone out of business probably is too high risk, and I wouldn't venture down that road. But a company that exists and it's an older model, and for continuity and being able to say, I have exactly the same line set up, okay, you can work through that and you accept that risk, but accept the risk that you may not get all the data off that equipment. You may not be able to do the analytics that's going to keep you competitive, ahead of the curve. Where if you invest in that new technology platform for the line, then they're going to give you a whole lot more analytical data than you ever had before. You're going to have more connectivity options, and you're going to be in a world where you have so much data, it's all about mining it then, instead of saying, why don't I have this data point? And I just lost 100,000 cells today because of it. You don't want to be in that position.
Okay, let's shift gears slightly and talk a little bit about digitalization. Obviously, this has been a common thread coming up through a lot of these questions. What role does digitalization play in helping US battery manufacturers overcome some of their supply chain risks and tariff challenges?
It's a really critical role, actually, because with digitalization, you can overcome supply chain risks, tariff challenges, and provide enhanced visibility to your shop floor, because you're going to get that real-time data, and you're going to be able to then use that real-time data for predictions, to be able to do trend identifications, machine learning, so the system works for you. And that happens through technologies like IoT platforms and MES, and then being able to aggregate that data up to an ERP system that's going to manage all your financials. One of the key things is that you want to be able to track the materials and then be able to optimize the consumptions and then procurement and adjust the production schedules based on responses to disruptions to the supply chain. Maybe a machine broke down, or maybe a tariff kind of changed the materials that you're going to buy from a different supplier, and that causes a change. These tools really enable better forecasting, decision making through the integration of automation, and this overall ensures more optimization to how you operate. And when you do that, you reduce the impacts. You reduce the impacts to quality, to production downtimes, to supply chain.
So this year was really all about supply chains. That everybody knows what's going on with tariffs. There's a lot of uncertainty in the markets. Battery makers, scratching their heads, trying to look where am I going to get my cathode materials, where I'm going to buy my machines. projects are being delayed because of all that. It's really a puzzle. That's where digitalization makes a big difference. Siemens tools like Teamcenter and supply chain collaboration give manufacturers a full digital view of their suppliers. And they help them to track materials origin, which is important, for example, for a battery passport. But there's also something similar coming up in the US. You have to prove that your materials that you use in your batteries don't come from the countries of concern. So digital tools help you to track materials, the origin, the cost, and simulate what-if scenarios. What if this supplier is not available anymore, or I can't use it, or it will be too expensive for me because I will be hit by big tariffs. With supply frame and Siemens cost management, companies can quickly model new sourcing strategies or reconfigure production to work with alternative components, keeping lines running while competitors scramble.
And Katerina, one thing that's happened is in the US market, there's incentives about where you source materials from what country. So traceability is really important. So on the shop floor, you'll have that full traceability of what materials from what suppliers, from what lots were consumed, so you can have full visibility, because there's incentives by the government to use materials sourced from certain locations. So that's an excellent example of the supply chain management tool.
So it sounds like digitalization really is all about getting data, obviously, but doing something with that data, having information that will help you make better decisions, real-time data based on exactly where that material is, where did it come from, so that you can respond to those ever-changing regulations and tariffs and supply chain challenges. Okay, interesting.
Yeah, so for example, companies working with different vendors, it's sometimes gets really difficult to plan ahead. And tools like Ops Center, advanced planning and scheduling can help you to smooth out with volatility, letting you rebalance production schedules in response to delays or cost swings, and to avoid expensive downtime. With Teamcenter, also you can test how material substitution or processes. If you are anticipating that some of the materials that you are using in your manufacturing today will not be available or become too expensive in the future, you can start preparing by using tools like Teamcenter. You can test how new chemistries or new materials will perform in a battery cell and affect performance of batteries, and it will just help you to be more resilient towards all these shifts.
To be ready, basically,
to be
when
ready, yes.
something comes up that it will, to force you to change directions, you have a couple options.
Exactly, at least you already have a model and okay, if that doesn't go, if this is not a good way to go anymore, I have this alternative, I have a plan B.
In that, the tools really help you, because there's, I'll call it planning, which is long term. You want to be able to see, okay, a material supply chain challenge is coming ahead. I need to evaluate alternate materials, make sure my chemistry still meets my yields. When you decide to do cylinder or pouches on the line and you want to switch those around, you can use the scheduling tool to kind of optimize that. Okay, I need to change this line. I'm going to impact these other production needs, and that way focus on the demand. And the demand is going to be a bit more profitable, right? Right now, these startups, you have to make the most profitable decisions. You're not going to ship the product that has the least profitability, but the most profitability, because it's all about momentum.
Sounds like this ties back to a very common theme: flexibility, agility, being able to make quick decisions because of all the uncertainty and change. And so using these tools from Siemens to digitalize and gather all this data so that you can make those quick decisions is crucial, it sounds like. Great.
Quick as well as long-term decisions. You have to prepare for the future. Because battery industry is so new, there is so much innovation and development still going on. You want to be prepared for what future brings. Yeah, so the bottom line, digitalization gives battery manufacturers a transparency, agility, and speed to not just survive disruptions, but also make them into a competitive advantage.
Okay, so beyond just mitigating risk, digital tools are helping speed things up. In practical terms, how can digital solutions help these new battery facilities and battery manufacturers become operational more quickly and more reliably?
Simply, a digital solution like an MES, manufacturing execution system, helps these facilities operate faster because all your processes are digitized to begin with. And you can more reliably, in a centralized location, monitor your production and everything that happens, from the material consumptions to data collections to defects that are happening on the shop floor. And this allows you to optimize production right from the start. You'll have that data, and through iterations, your process will get more and more refined. So by leveraging the MES system, battery manufacturing sites can really reduce operational ramp-up time, maximize capacity, maximize yield, because you're leveraging the tool set to make the manufacturing process smooth.
Honestly, getting a new battery facility off the ground quickly and without costly mistakes is not a small task. But that's exactly where digital tools come into play. They help you to reduce risk, to move fast at every stage, from early planning to full production. Instead of waiting until the plant is built and see how things work on the shop floor, you can create a virtual model of the entire facility and simulate how materials, machines, and even people move through your plant. And that means you can test different layouts, spot bottlenecks, and make smart changes before construction even starts. On top of that, you can simulate how automation systems and control logic will behave before a physical equipment is installed, which helps cut weeks or even months out of the commissioning process. And because everything is connected digitally, any updates to battery design, like changes to the cell or pack configuration, like you mentioned, going from pouch to cylindrical, automatically feeds back into your production planning. That keeps your design and manufacturing teams aligned from the day one. And training the workforce is another big challenge, especially in regions that don't have experience in battery manufacturing. Digital work instructions and immersive training tools, even VR sets, let you onboard people before the line is live, so they're ready to go from day one. Once the facility is up and running, digital systems help monitor quality and performance at every step, allowing you to catch issues early and maintain high standards. And even after launch, simulation tools let you keep improving the process, modeling things like thermal behavior or mechanical stress of battery packs without having to stop production. So in practical terms, digital solutions let you simulate first, train early, and validate virtually, and stay connected all the way through. It's smarter and faster way to do things.
It sounds like it's pretty much a must to compete today, to have these digital tools in order to prove out all these processes and all these technologies before investing all this capital in new equipment and layouts and new plants, to be able to prove it all out before spending all that money, basically.
Yeah, especially in nowadays market, it's very difficult to raise fresh capital. Yes. So you don't even have this money to spend, so you have to work smarter.
Yeah, everyone's very challenged to get that startup funding for that next battery venture compared to maybe 10 years ago where it was a little easier. Yeah. Interesting. Okay, great.